So in this video, we're going to be taking a look at the ClimateSERV Graphical User Interface, or GUI, which is a website that allows you to visualize, analyze, and download both historical and forecasted data. So to access ClimateSERV, I'm just going to open my browser window and type in ClimateSERV into the search bar, and we'll go ahead and click the first link that pops up. So this will bring you to the ClimateSERV homepage, and we'll see how to access the user interface in a little bit. So as you can see, we have these three tabs up at the top. Right now we're on the homepage, which provides you with some background knowledge on ClimateSERV, as well as how you can use it. If we click the Map tab, that will bring us to the user interface, which we'll cover shortly. And then if we click the About tab, we get some more information about why Servier developed ClimateSERV in the first place, what the purpose of the application is, more information about the data sets, and finally, what are the use cases of our end users that utilize this tool. Finally, we have the Help Center tab at the top right here. And within here, we have three different sections. First is the dataset metadata. So this provides you with a lot of background information on the different data sets that are available within ClimateSERV. You also have this user interface tab here, which provides you with help with the different features of the user interface. And then you have the developers API, which provides more resources for the application programming interface associated with ClimateSERV. But in this video, we're just going to be covering the user interface. So we'll go ahead and access the user interface again by clicking that Map tab in the top right. So as you can see, this is the home page of ClimateSERV. It will just start by showing you a base map, and then we can add data or data requests on top of that base map here on the left-hand side with the statistical query panel or the layers panel. And then finally, we have a base maps panel at the bottom left there, and that is just how we can change the default base map within ClimateSERV. So we started with a satellite imagery base map, but we can turn on a topographic map if we so choose. So the statistical query panel is going to be really good for either downloading data or seeing how data varies across a period of time for a particular area of interest. But the layers panel is going to be better suited for viewing how that data changes over space, or using the animation feature over both space and time simultaneously. So let's say I wanted to use the layers panel to see how soil moisture data varied for a region of interest. So first I would zoom to my region of interest, which I'll just pick a random area of interest right now. And then I would use the ClimateSERV Dataset Encyclopedia, which we learned about in the last unit, to discover what different types of soil moisture data I can find in ClimateSERV. So I have that pulled up right here, and we can see in the table of contents that if I'm looking for historical data, I have two options when it comes to historical soil moisture data. I have what's called the USDA SMAP dataset, and I have the NSIDC SMAP dataset. So these datasets are fundamentally the same in that they come from the SMAP, or soil moisture active passive sensor, but they're different in the fact that the processing workflows change the resolution of the data. So this USDA SMAP dataset is at the native resolution of the sensor of 10 kilometers, whereas this NSIDC dataset has been downscaled to 1 kilometer. So if I wanted to look at soil moisture on sort of a finer scale, I would probably pick this NSIDC data, and looking in the encyclopedia here, we can see that we have two different subsets of this data, the first being a daily acquisition and the second being a 15-day composite. So this 15-day composite is going to provide broader spatial coverage, but of course it's going to have less temporal resolution. So since my area of interest is pretty big, and just for the purposes of this demo, I'm going to go ahead and use that 15-day composite. So I could either scroll down to find the data set here, or I could filter the data set And we can see that we have that raw data and then the 15-day composite here. So if I want to visualize the 15-day composite, all I need to do is check the box there, and we'll get the most recent acquisition available in ClimateSERV. So down at the bottom there, you can see that this particular overpass was in January 23rd of 2024, and you can see the time there as well. So now I'm going to walk through the different settings that you can tweak in the visualization of these layers. So first, I'm going to click this icon here to bring up the legend, and that will also show you the units of the data set. And so here we can see that colder colors like blue and purple represent drier areas, whereas those warmer colors like red and orange represent wetter areas. So to sort of tweak these visualization parameters, we can use this gear icon on the bottom right here. And so when we pulled up our legend, we could see that we're not seeing a lot of red and orange in this map, and that's just because for this particular acquisition, the maximum soil moisture seems to be closer to around 0.5 or 0.6, maybe even 0.75, because we're getting a little bit of orange. But it's not reaching that maximum possible value of 1. So if we want to stretch the visualization out a little bit more, we may choose to set our maximum value to 0.75 instead of 1. And we can do that within our settings by changing the max value there. And then you just hit apply, and we can see that now our maximum value is 0.75, and we're able to get a better understanding of how the soil moisture is changing in the region. The other settings we can change include the color scheme that we use to display the data. And again, you need to hit apply for any of these to take effect. And then we can also change the above max color and below min color. And what that will do is it will take values that fall above your maximum and either use the same color as the maximum value if you click extend, or if you click transparent, values that fall above the max color will be transparent. And same goes for the below min color. And then our final option in the settings tab is the opacity. So this will allow you to see the base map underneath better and give you a better idea of where in the region you are. So those are the different settings that we can change within the layers panel. And right now we're just looking at a single acquisition, right? We're just looking at the acquisition from January 23rd. But what if I want to see how data in my region of interest varies over both space and time simultaneously? Well, I can do that in the layers panel as well, but I'm going to want to change the date range down at the bottom here. And this will provide us with an animation of this data over time. So first I'm going to set the opacity back to 1. And now I'm going to select the date range that I want to look at. So let's say my time period of interest was just in the most recent 3 months. So I would go back to November of 2023 and set my start date and end date, and then I'll click set range. And we can see that ClimateSERV has now brought us back to October of 2023, and we can step through each of these acquisitions by clicking the forward tab here to see how soil moisture changes at each acquisition. Or we can go back to the beginning and press play, and ClimateSERV will give us a nice animation through that data. If I want to change the speed at which it's animating through, I can change the FPS slider there. And I can also go backwards in time, and I can flip through the different slides by clicking this back arrow here. So this will go backwards in time, and this button will go forwards in time, frame by frame. So that is basically it for the layers panel. Next, we're going to look at the statistical query panel, which is better for seeing how your data varies over time using an average value across your region of interest. So I'll go ahead and click over to the statistical query panel, and we'll look at the same data for the same region of interest, but now we'll get a better idea of how it changes over time using an average value instead of looking at the raster data as we just did. So as you can see in the statistical query panel, our first order of business is going to be setting the area of interest, and we have three different ways we can do that. We can use the draw function, the upload function, or the select function. So if I click the select function, you can see that you can pick an entire country as your area of interest, but in this case we want to get a little bit more specific. So I'll click admin 1, which will show in black kind of the outlines of the different provinces in this region, and if I want to get even more specific, I can click admin 2, but admin 2 is actually only for severe focus countries, so in this case it's not going to work for this region of interest. But if I was working in Africa or the Amazonia region or South and Southeast Asia, I could use admin number 2. But in this case, we are going to use admin number 1, and if I click one of those provinces, we can see that it's highlighted in yellow. So that's one way to specify your area of interest, but let's say you didn't want to use a administrative boundary and instead you wanted to use a custom AOI. If that was the case, you'd want to use the draw or the upload function. So you can draw, using the draw function, you can click here to draw a polygon. You can also do a rectangle or just a simple point. So let's go ahead and draw a custom area of interest. You can then delete that area of interest or edit it further here, but I think that looks good, so we'll go ahead and work with that area of interest. You can also upload your own JSON or GeoJSON or zipped shapefile to have your custom area of interest uploaded to ClimateSERV. So after we specify our area of interest, what we're going to do now is select the type of request we want to submit to ClimateSERV, as well as the data that we actually want to visualize or download. So there's three different types of requests that we can submit in the statistical query panel. We have a time series analysis, which is what we're going to look at now. We can download that raw data, or we can look at a monthly rainfall analysis. We're going to start with time series analysis and look at the soil moisture as we just did. And in this case, recall that NSIDC data is an observation. It's a historical data set. It's not a forecast, so I'll click observation there, and then I will go ahead and select the data set from the drop-down menu here. Now this calculation tab is going to take all of the pixels that are available within our region of interest, and for a single day it's going to reduce all of those pixel values to a single value. So maybe I can bring up the layers tab to display this concept a little bit better. And let me change the opacity here. So we can see that we have probably thousands of pixels falling within our region of interest here. And so for a single acquisition, we need to tell ClimateSERV how we want it to take each of those values for each pixel and give us a single value for that date of acquisition. So we have three ways that we can do that. We have an average, we can use the minimum pixel value, or we can use the maximum pixel value. And you may be familiar with this concept as a spatial reducer. So in this case, I'm going to use the average, and then I'm going to pick my date range. So again, let's go from November of 2023 to present day. And I just select those by clicking, and we will set it to January 31st. So we can see I'm submitting a time series analysis request to ClimateSERV for 3 months of data, and that is the soil moisture data I want. So we'll go ahead and click Add Query. We can see that it finished it already, so we can click Submit One Query. And then you can see the progress bar loading here. And when this is done, it'll show us a nice graph of our soil moisture over time. We can see that we got a discontinuity in the middle here because there was some missing data in the SMAP data set. And that's when the ClimateSERV data set encyclopedia will be really helpful for seeing where we can get bad or missing data for certain regions of interest and for certain times. So the other thing that we can do in the statistical query tab within ClimateSERV is to download these raw raster data to our computer. So if I click download raw data instead of time series analysis, using the same parameters, instead of visualizing the data, I can download these raw TIFF files to my laptop. You can use TIFF files or you can use netcdf, whichever you prefer. So if I click TIFF, because that's the file format that I prefer to work with, using that same date range, I will go ahead and click Submit Query. We can see that our file download is ready, and I just simply click there to download the file. It will download as a zip file, but if I expand that zip file, and I should use the NSIDC SMAP dataset, and I'll click Submit Query. Re-download it, and we can see if I open my Finder and my downloads that it downloads as a zip file, and if I open that zip file, we can see that I have these different TIFF files, and the date of the acquisition of that file will be written on there as well. So we can see that we have an acquisition from November 8th going all the way up until January 23rd. And finally, we can do a monthly rainfall analysis in ClimateSERV using the statistical query panel, and this of course is only if you want to look at precipitation, but this will give you a good idea of how the precipitation in the season is varying compared to the historical data, and that comes from ClimateSERV as well. So we can see that the long-term average is shown in blue here, and the seasonal forecast for this season going into the future until June of 2024, we can see that the precipitation is forecasted to be higher at the beginning than the long-term average, but then in May and June is projected to be lower than the average and even lower than the 25th percentile. So again, this is more useful if you're looking at precipitation in the region. And so those are the three different ways that we can interact with data using the statistical query panel. So that does it for this video. In the next video, we're going to take a look at the ClimateSERV API, or Application Programming Interface, which allows you to implement all of the functionality that you just saw with the user interface within a programming environment. So I'll see you next time. ClimateSERV was developed by Servier's Science Coordination Office, specifically by Ashutosh Lemay, Brent Roberts, Eric Anderson, Billy Ashmall, Githika Tundapu, Francisco Delgado, Roberto Fontanarosa, Lance Gilliland, and Alex Goberna. The curriculum materials were organized by Servier's Science Coordination Office. Individual modules were created by myself, Mickey Maganini, and Billy Ashmall. Crucial insight regarding the creation of the curriculum materials was provided by Dr. Roshanak Darvishzada. Review of the material was conducted by Servier's Science Coordination Office, specifically Brent Roberts, Meryl Kruskopf, Ashutosh Lemay, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthin, Natalia Bermudez, Stephanie Melick, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Emil Sherrington, Francisco Delgado, Biplav Bhandari, and Amanda Markert. Review of the materials was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geoinformation Science and Earth Observation at the University of Twente. The course and banner images were created by Gianluca Ambrosi of ITC.